In this tutorial, you'll learn how to set up the linear elastic bonded model in EDEM. This model is typically used for modeling rocks and soil-type materials. First, set the required units for the simulation. You got the option to add a title and description. Add a new bulk material and define its properties. Next, add a single sphere particle shape and set its physical radius and contact radius. Ensure the contact radius between particles exceeds the physical radius, as it defines the bonding area. The contact radius is important as it determines the area in which a bond can exist. When the particles no longer overlap, the bond information is lost. A bond will be formed in the first time step of the simulation only. After these initial bonds have been created, no new bonds will be formed. Add a size distribution with the following properties. Define the equipment material and its respective properties. Next, create a loading plate by generating a polygon. You can adjust the geometry's position from the transform section. Setting the number of edges and the radius. Then, add a linear translation kinematic with the specified properties. Next, create the base plate geometry, following the compression plate's steps but without motion. To generate particles in the simulation, create a virtual cylinder geometry with the following dimensions. Add a volume packing factory to the cylinder and define its parameters. Moving to the physics section, select the contact models for the simulation. Select No Base Model, as this is to be replaced with the linear elastic bonding model, which includes the base component. Configure the model, add material interactions and relevant parameters to the model. After setting up the model in the Creator, move to the EDEM simulator. First, uncheck the Auto Time Step checkbox and set a time step value. Finally, set the total simulation time to 2 seconds and the target save interval to 0.01 seconds to determine the write-out frequency. You can choose between GPU and CPU for the solver engines. If CPU is chosen, ensure the correct grid size is specified. We can then proceed and run the simulation. After the simulation is complete, you can move to the EDEM Analyst to post-process the results. In the Display section, adjust the geometry's opacity to 0.7 for clarity. Hide the cylindrical particle factory to better visualize the results. Configure the particles by setting their color based on the property you would like to see. Our relevant properties would be the custom bonds initial or the custom bonds damage. Uncheck the Display All Particles checkbox and apply it to all. Next, we can go to the Contacts section and configure the bonds. Select the particles and set its contact with your particle again and check the Display Contacts box. You can color the contacts using several properties such as the custom initial overlap, the bond status, and the custom shear force. We can then move to the Plot Graph tool in the EDEM Analyst and plot the results. Under Group, we will select Geometry, under Section we will select Compression Plate, and we will plot the total magnitude of the total force on the y-axis. The data can be exported out of EDEM to compute other metrics, such as stress versus strain for the compression sample.